Water rushes over smooth stones, sunlight dances on the ripples, and somewhere, beneath a layer of pebbles and sand, lies a treasure forged billions of years ago. A diamond, unpolished, untouched, waiting for the one who knows where to look and how to see what others miss. You don't need a metal pan. You don't need fancy screens or high-tech gadgets. Nature has its own way of revealing diamonds if you can read her clues. Today we are going deep into the art of spotting diamonds in streams, with nothing but your eyes, your hands, and your patience. The first secret: diamonds don't look like jewelry. Forget the glittering, perfect gemstones you've seen in a shop window. In their raw form, diamonds often look like dull, greasy pebbles, transparent, off-white, or faintly tinted yellow or brown. Many first-time seekers walk right past them because they expect brilliance. But in the wild, brilliance is muted. Instead, look for an unusual sheen. Diamonds have a distinct waxy or greasy surface luster. When wet, they don't sparkle like quartz. They glow softly, almost as if light sits inside them rather than bouncing off. A diamond's journey begins deep underground in volcanic pipes made of Kimberlite or Lamproite. Over millions of years, erosion breaks down these rocks, freeing the diamonds and carrying them into rivers and streams. The water acts like a natural conveyor belt, moving heavy minerals, gold, garnets, magnetite, and yes, diamonds downstream. But unlike lighter stones, diamonds are dense. They settle in specific spots where the current slows. And those spots are the key. Walk along a stream after a period of rain when water has shifted sand and exposed new layers. Study the inside bends of the stream, places where water curves and slows, allowing heavier materials to sink. Pay attention to gravel pockets between larger rocks, behind natural obstructions like logs or boulders, shallow depressions in bedrock where pebbles gather. These are natural catch points. Diamonds can rest here for decades, even centuries untouched. When you find the streaks of black sand in a stream bed, you've found a concentration of heavy minerals. While black sand is mostly magnetite or hematite, it's a sign you're in a high-density material zone, exactly where diamonds can also settle. In these zones, sift gently through the top layer with your hands. Let the lighter sand wash away and see what remains in the palm of your hand. Look for any small, translucent, or oddly greasy pebbles. Streams are filled with quartz and other clear minerals that can trick you. But here's the difference. Quartz will sparkle with sharp flashes in sunlight. Diamonds give off a muted, oily glow, even in shadow. Hold the pebble underwater. Diamonds remain visible in a way quartz often doesn't. They refuse to disappear into the water's shimmer. Another quick sign. Diamonds often have rounded edges from tumbling in the stream, but their surface feels slightly rough, almost like fine sandpaper. Without a pan, your greatest tools are your hands and patience. Kneel at a likely spot, scoop up small handfuls of gravel and sand, letting the water wash away lighter particles. You're left with heavier materials, tiny garnets, ironstone, and if you're lucky, a diamond. Work slowly. A single scoop can hide a stone worth more than anything else you'll find all day. Even if you don't see a diamond immediately, certain minerals can tell you you're close. Garnets, often red or pink, commonly travel with diamonds, chromite. Dark metallic-looking grains, ilmenite, black with a subtle metallic sheen. If these are in abundance, the source of diamonds might be nearby or upstream. The time of day can be the difference between spotting a diamond and walking past it. Early morning or late afternoon light is softer and lower, which enhances the greasy glow of diamonds. Midday glare can hide them completely. Try walking upstream in the morning with the sun at your back. Let the light strike the gravel at a low angle. You may see that faint, otherworldly shine that no other stone can mimic. Streams change over time. Seasonal floods carve new channels, exposing previously buried gravel beds. Old channels, now dry or reduced to trickles, can be rich hunting grounds. Look for places where the stream once flowed. These old beds can be as valuable as the current one. The diamonds there have been resting for centuries, untouched by anyone who didn't know where to look. Finding diamonds in streams without a pan is less about luck and more about attention. Every rock, every handful of gravel is a potential jackpot. The moment you rush, you miss the signs. When your fingers sift through cool water, you're not just searching for a stone. You're touching a piece of the Earth's deepest history. The water narrows, rushing faster, then slows into a deep, calm pool. To most, it's just another bend in the stream. But to the trained eye, this is a natural diamond vault, a place where the current has quietly deposited treasures for centuries. Now we go deeper, into techniques so precise that old prospectors swore by them long before metal pans and machines existed. Every stream has sections where the bedrock is exposed. Over time, water carves tiny cracks, grooves, and potholes into it. These are nature's gold and diamond safes. To search, position yourself in shallow water. Run your fingers along the bedrock, feeling for crevices. Scoop out the gravel inside and wash it gently in your hands. These bedrock traps are especially powerful in older streams that have cut through ancient volcanic rock, possibly sourced from Kimberlite pipes upstream. In certain parts of a stream, currents collide at an angle, creating swirling eddies. These swirling zones naturally filter out lighter materials, concentrating dense minerals at the bottom. Stand still and watch the surface for a few minutes. The water itself will reveal where the current slows, spins, and drops its load. That's where you dig, with nothing more than your hands. Midday light can drown the subtle glow of a diamond, but shaded areas, under overhanging trees or alongside steep banks, can act like natural filters. In these zones, even a small diamond becomes more visible. In shadow, look for stones that don't just reflect light, but seem to emit a faint, deep glow. That's the greasy luster unique to diamonds. You find a small, clear pebble. Could it be quartz or diamond? Without tools, the wet surface test can help. Hold the stone underwater, rotate it slowly. Quartz often loses its visibility and blends into the water's shimmer. Diamonds remain distinctly visible, as if water cannot hide them. If it passes this test, it's worth keeping for further inspection later. In the dry season, water levels drop, exposing gravel bars and deeper parts of the stream bed. These newly uncovered areas may hold diamonds untouched by human hands. In the rainy season, heavy floods bring fresh material downstream, potentially from new erosion points in diamond-bearing terrain. Both seasons have their advantages, so your search should follow nature's rhythm. Sometimes the key to stream diamonds lies above the water. Look for signs of kimberlite boulders or indicator minerals scattered along the banks. A cluster of garnets, chrome diopside, or black ilmenite grains upstream can signal that diamonds may have been washed into the stream below. Every stream you explore is part of a larger ecosystem. Disturb it gently. Move stones back after checking them. Let the water flow as it always has. The less you alter the stream, the more likely it will continue to produce treasures for generations. Before you leave a spot, take one last slow walk along the bank, scanning the shallow edges. Diamonds can appear when you least expect them, after your eyes have adjusted to the patterns of the gravel. That's when anomalies stand out. Sometimes the best find of the day happens when you're already thinking about going home. Finding diamonds in streams without a pan isn't just a skill, it's an art form. It's about slowing down, letting the stream tell its story, and reading every ripple and stone like a page in an ancient book. Each diamond is more than just a gemstone. It's a time capsule from deep within the earth, carried through volcanic eruptions, ancient rivers, and countless seasons until it came to rest at your feet. You don't need a pan. You don't need chemicals. You just need to look and truly see. Because somewhere in a stream not far from here, another diamond waits, hidden in plain sight, until the moment your hands find it. Every stream tells a story, but only those who truly listen will ever hear it. Diamonds are not found by rushing nor by wishing. They reveal themselves to the patient, the observant, and the respectful. Long before pans, machines, or laboratories, humans found these treasures with nothing but their eyes and their hands, guided by instinct and the quiet signs of nature. Somewhere under the shimmer of running water, a stone older than time itself lies waiting, not to be taken in greed, but discovered in awe. And when you hold it for the first time, you'll know you've touched the heartbeat of the earth. So the next time you stand by a stream, remember, It could be just another river to the world, or it could be the one that changes your life forever. You're walking through a landscape of deep, rusty red earth, dry, dusty, unassuming. But what if I told you this crimson ground could be hiding some of the rarest blue gemstones on Earth? What if the very soil beneath your feet was quietly guarding a geologic treasure trove? Stick with me, because by the time we're done, you'll never see red dirt the same way again. Red soil has long been associated with iron oxide, the rust-colored signature of ancient geological transformations. But what many don't realize is that this environment doesn't just hint at iron-rich terrain. It can also be a bold, glowing beacon, signaling the presence of deep blue gemstones hidden within. Let's begin with a surprising one: sapphire's hidden cousin, blue spinel. Found in metamorphic environments where aluminum and magnesium are present, blue spinel often forms in regions where iron-rich soil dominates the surface. This is particularly true in parts of Southeast Asia and Africa, where red soil is common due to the breakdown of ultramafic rocks. When these rocks weather, they don't just leave behind iron, they leave a cocktail of minerals capable of producing blue spinel deep underground. Now consider this: the presence of laterite, a red soil type rich in iron and aluminum, isn't just a mark of intense weathering. In geological terms, it's a spotlight. Why? Because laterite forms from the breakdown of basalt and gabbro, rocks known to host corundum. That's right, blue sapphire. In several mining regions in Sri Lanka and Madagascar, the red soil is littered with tiny glassy particles, remnants of eroded sapphire-bearing deposits. But how do you trace sapphire or spinel in a sea of red earth? The answer lies in gravels, concentrations of heavier minerals within riverbeds and slope bottoms. In tropical or subtropical areas, red soil forms rapidly and erodes constantly, causing heavier gemstones to sink and settle. This process, known as alluvial concentration, turns red earth from barren terrain into a gemstone hunter's map. There's a story out of Tanzania where locals found a stretch of deep red soil cutting across a plateau. Thought to be useless farmland, but just beneath the surface they struck veins of cordierite, another blue gem often mistaken for sapphire. This aluminum-rich stone forms in metamorphic environments, often close to gneiss or schist, which are abundant beneath ferric laterite zones. But blue isn't just limited to transparent gems. Let's talk about dumortierite, a fibrous, vibrant blue mineral that's often embedded within quartz. While not typically considered a precious gemstone, dumortierite's vivid hue and rarity make it a collector's dream. And yes, it too appears beneath oxidized red soils, especially where volcanic activity once stirred up the Earth's mantle. There's a pattern forming here. Red earth, once dismissed as infertile or worthless, seems to whisper secrets. It speaks of extreme heat, volcanic fire, metamorphic pressure, all of which are necessary to forge brilliant blue stones. Even in regions like Myanmar, where sapphire mines run deep, miners often trace the gem's origin by analyzing overlying soil patterns. Rich red earth often leads to deeper deposits, a breadcrumb trail for the observant. But sometimes it's the presence of aluminum-rich host rocks beneath this red cover that gives rise to blue stones. These rocks, like basalt, gneiss, and pegmatite, often lie buried beneath red tropical soils, waiting to be unearthed. And when ground moisture leaches away iron, it can leave behind pockets where gemstones accumulate, clues hiding in color. Let's explore an often overlooked sign: blue mineral staining in red soil. When trace amounts of copper or aluminum leach from deep rock layers, they may oxidize near the surface, turning patches of red earth subtly purple or blue. These discolorations can be clues, pointing to the presence of secondary minerals like azurite or chrysocolla. both rich in blue tones and both hinting at even deeper mineral riches below. The great irony is this: where most people see lifeless, hot, rusty soil, professional gem hunters see contrast. The deep red provides a perfect canvas for spotting the occasional glint of something extraordinary. Even under the blazing sun, those flashes of color, iridescent, sometimes almost metallic, stand out in ways they wouldn't in darker or greener environments. Think of the red soil as a kind of geological canvas. Every crack, every grain tells a story. It's in these transitions between red and blue, dry and wet, soft and solid, that nature's most guarded treasures hide. But it takes trained eyes to notice them. In Australia, where opals and sapphires are routinely found in iron-rich outback soils, miners often begin their surveys not with tools, but by reading the landscape's color palette. Because here's the truth: color always leads, and red isn't the end of the story. In gemstone lore, it's often the beginning. So if you've ever dismissed red soil as poor ground, think again. You may have walked over blue treasures without ever knowing it. Somewhere deep in Madagascar's remote highlands, red soils streak the hills like rivers of rust. But hiding beneath them, nearly invisible without the right eye, is a beryl cousin so rare it makes even aquamarines jealous. This is where you'll find indicolite tourmaline, a gemstone painted in electric blues and teals, often growing in harmony with pinks and greens inside weathered pegmatites that have been bleeding minerals for millions of years. That iron-rich red dirt? It's the signature, the fingerprint of ancient hydrothermal chaos. Now let's head to Brazil, specifically the legendary region of Minas Gerais. The hills there aren't just red, they burn crimson under the sun. And they carry a secret. Beneath that fiery surface lie veins of hidden imperial topaz and ultramarine fluorapatite. The mineral-rich laterite soils formed from deep tropical weathering may look ordinary, but when cracked open, they sometimes spill gems that mirror the sky. But what causes this strange pairing of red earth and blue brilliance? It's all about iron. Red soil is usually the product of iron oxides like hematite and goethite. In the same regions where iron-rich fluids once surged through fractures, they often dragged along other metals, lithium, boron, beryllium, forming the elemental cocktail required to grow blue gemstones like sapphire, kyanite, or even dumortierite. It's a geologic paradox: red above, blue below. In Tanzania, the famed Merelani Hills tell another story. While they're best known for tanzanite, few realize the surrounding red soils, dyed by the presence of garnet and iron, also hide veins of zoisite and rare blue-green sapphires. These stones don't always come out clean or polished. Some are crusted in host rock, their glow hidden beneath grime and weathered crystal faces. Closer to the Himalayas, parts of Nepal and northern India are marked by rich red lateritic zones. Prospectors rarely give them a second look. But if they did, they might discover a secret: stunning blue spinels lying dormant inside ultramafic intrusions. Found only where tectonic plates once crushed oceans into mountain ranges, these spinels shimmer like sapphires but carry none of the fame, only the raw beauty of deep earth pressure. Let's not forget North America. In the southern United States, specifically Georgia and Alabama, thick red clay coats the landscape like a blanket. Beneath these soils, kyanite, a mineral that may not scream gemstone until light hits its perfectly aligned crystals. It forms in metamorphic zones where the red earth tells a much older story of subduction, heat, and pressure. And there's one more place where the red meets the blue: the Australian outback. Here the soil is a deep, almost Mars-like red, dry, cracked, hostile. But inside the sandstone cavities of this unforgiving land lie precious opals, some black, some white, some with dazzling electric blues that ripple like oil on water. These opals form when groundwater, rich in silica, fills the voids in iron-stained sedimentary rock. When it dries out, it leaves behind liquid rainbows encased in stone. So what's the takeaway? Every time you see red soil, don't just assume it's empty. Look for the signs. Mineralized fractures, quartz veins, oddly colored stones, and ancient riverbeds now dry. Look for hardness, crystals that scratch glass, shine under UV, or react oddly to a magnet. Because red earth is not just the land's outer skin, it's a trail of clues left by time. And sometimes those clues point directly to a gem that's worth far more than the dirt hiding it. If you've walked on red earth, you may have been closer to a rare gemstone than you ever imagined. These blue beauties don't scream for attention. They whisper from the shadows, from iron-scarred hills, from ancient hydrothermal chambers, and from the dust beneath your boots. So the next time you find yourself standing on crimson soil, ask, what's buried just beneath the surface? Because in the world of gemstones, the loudest treasures are often hidden in the quietest places.